Hello everyone, welcome to my channel Indian School of Physics. This is Nitin here, and today again I have come up with a very amazing problem. It is oscillations of n-sided polygon with the springs. So guys, this video is presented by Indian School of Physics and Unacademy together, and name of this problem is oscillations of n-sided polygon with the springs. My upcoming courses on Unacademy are modern physics, fluids, gravitation, waves and thermodynamics. And modern physics and waves will be starting very soon, within 1 week, and there will be free special classes for JEE physics at Unacademy. So guys, you can take a note that 30th November till 5th December there will be specific classes for JEE Mains 2021. So don't forget to attend these classes. And if you want to study with me on Unacademy, this is my code Nitin sir, you can use it. And yes, physics will never be the same again. For more info, you can visit Unacademy website, which is www.unacademy.com. So here is the statement of this problem. Suppose we construct a regular convex polygon with n sides. Basically a regular polygon we are taking, an n-sided polygon. Massive point particles reside at the vertices and the particles are connected by massless ideal springs shown as blue lines. Instead of blue, I am using these dark lines. So these are the particles, and springs are connected between them. All right. Let the individual particle masses and individual spring constant be defined as follows for n greater than or equal to 3. So mass of each particle is m0 by n, and spring constant is nk0. That means if I am using 3 springs, they are 3k, 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 and masses are m0 by 3, m0 by 3, m0 by 3. In this case, I am going to take m0 by 4, m0 by 4, m0 by 4, and this m0 by 4, while spring constant is 4k, 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 4k. This is how in the problem statement it is defined. Suppose the n-gon oscillates by expanding and contracting periodically without altering its shape. The limiting value of angular frequency of oscillation as n tend towards infinity can be expressed as omega infinity is equal to some alpha times under root of k0 by m0. So we have to find the value of this alpha, and we have to neglect the mutual gravitational force between the particles. So let's discuss this very important problem, guys. Very amazing problem. It was given by one of my students to me, and I kind of liked it, so I thought I'll make a video on it, and it is within JEE syllabus and a very nice problem. So for n-sided, this kind of situation, we will have this angle. I can write this is going to be 2 pi by n. So here, let's say for n-sided polygon, this is the equilibrium position here. You can extend these angles, and n-sided polygon you can complete. So I'm looking at one particle alone. So in equilibrium, forces are balanced on this, and these springs are relaxed. Now radially, these particles, let's say they are displaced by a displacement of x. All right. So in that case, this is another link here, this is another link here. Particles are present at these locations also. So you can see even this particle will go by x, this particle also will go by x. So you will see this spring is going to stretch. In fact, all these springs are going to stretch here. All right. So if this angle I take as alpha, so you can see some stretching is taking place at this end here. We can construct this right angle triangle, and this x is very small in this case. So you can see this is roughly x cos alpha. Though the values will come true for any x, but I am taking a small x. So here you can see in this triangle, you will be getting this extension from this particle in the spring is x cos alpha. Similar thing will happen at other end also. That is going to be x cos alpha as well. So total extension in each spring is going to be 2x cos alpha if particle is displaced by a distance of x. Now this angle is theta, which is 2 pi by n. I have written here. So this angle is going to be pi by 2 minus theta by 2. All right, this is going to be pi by 2 minus theta by 2. All right, because this angle and this sum is going to be pi. I have taken this angle alpha, which is pi by 2 minus theta by 2. I have just explained you this part, that extension here is 2x cos alpha. So the spring force which is going to be present here is going to be k delta x in each spring, which is going to be 2kx sine theta by 2 if I substitute the values. So this force, as you can see in the diagram, is acting in this direction and acting in this direction. So the restoring force I can write along this line, along the bisector of these two forces, and the value is going to be 2f cos alpha, minus sign because of kinematics I'm putting. So alpha is pi by 2 minus theta by 2. So I can write this force as 2f sine theta by 2. I can write it as f restoring as mass into acceleration. So when I substitute the value of this f as k delta x, so you can see here this force is nothing but 2kx sine theta by 2 into sine theta by 2, and this is 2 also. So I'll be getting on simplifying and substituting the value of this mass also. For n-sided polygon, this mass is going to be m naught by n, and the spring constant is going to be nk naught. So these values, when I substitute here, this m becomes m naught by n, and this k becomes nk naught, and I can take this x outside. So in the bracket you will be getting 2 square nk naught sine square theta by 2. So when I bring these terms this side, you can see here I am going to get d2x by dt square plus 2 square n square, and this is k naught by m naught sine square theta by 2 times x. This is the equation of SHM. So motion is simple harmonic, and I can call this as omega square. So I'll be getting the value of this omega here, and theta value also I can substitute here, which is nothing but 2 pi by n. So when I substitute the value in this case, I'm going to get omega square is equal to 2 square n square k by m naught sine square pi by n. So when I write omega, it is going to be 2n sine pi by n root of k naught by m naught. Now you can see here, I can write this as this n, I'll multiply with pi and divide by pi, and since here it is pi by n, and I know n tending to infinity, that angle will be tending to 0. N tending to infinity, pi by n will be tending to 0. Alright, you can see here. So in this situation, I can take this limit as 1. That is what I am going to do. So you can see I'm multiplying with pi and divided by pi. So this n I can club with this pi. So sine theta by theta form I'm getting, and pi by n is tending to 0. So this limit becomes 1. So when I substitute the value of it as 1 and n tending to infinity, I'm calling this as omega infinity, as it was given in the problem. That comes as 2 pi under root of k naught by m naught. This is going to be the answer for this problem. And here he was asking the value of alpha. Omega infinity was given as alpha under root of k naught by m naught. So alpha value will come out to be 2 pi. This is going to be the final answer. I hope guys you have enjoyed this problem very much, and if you have enjoyed it, please leave a like, share this channel with others, and if you haven't subscribed my channel, please subscribe it. I'll be coming up very soon with another amazing problem. Thank you. Thanks for watching the video.